everyone. In the previous video, I have covered question 1 of our internal 1 examination of data science. And in this video, I am going to cover question number 2, 3 and 4 because these questions are interlinked. So for better understandability, I have covered all these 3 questions in the same video. So let's discuss question number 2, which is discuss specific methods or technology that facilitate this process. Given the following complaint, describe the approach, algorithms or process for identifying applicable Indian Penal Code or broad national category section. So here's the complaint of which we have to facilitate the process of complaint filing, and we have to identify the applicable IPC or BNS categories. So let's have a look of what complaint is. Test of my mobile phone by it would have been thief of my mobile phone by an unknown person at MG Road on 2023 to 20. The phone was stolen when I was shopping at a store. The thief was wearing a black jacket and had a scar on his face. So the answer for this question is to find the specific methods and technologies for text mining and classification. We have several procedures and then we can automate this process. So let's have a look on these technologies. For analyzing text complaints, we have to use a combination of natural language processing and machine learning models. So some of those technologies and methods are: first is pre-processing the text data. It involves text cleaning, like removing the unnecessary information such as stop words, and normalize the text by lowercasing whole text. Here in this, we can remove the words like was, and, at, on, and these prepositions, the words which are not needed here, and normalize the text like all of the text should be written in lowercase. Then we do tokenization, which is splitting the text into smaller units like words or phrases. Like this is a paragraph, we can split it into texts and then we can give them tokens which are unique. Then we have named entity recognition, which is extract the entities like date, which is very important that when that incident happened. Then locations, where that event or event not incident happened. Then object, like what have been theft, it is mobile phone. So these are recognized. Then we have context understanding and categorization, in under which we have semantic analysis and rule-based matching. So here we use embeddings like BERT or word2vec to capture the context of words, and we can map these key phrases to legal categories using the similarity scoring. And then we can create a keyword or phrase mapping system, like which keyword maps to which section or which code of this IPC. So like stolen word is connected with IPC 378 or 379. So we have to phrase these mappings and then combine the pattern matching tools for structured patterns like dates or location. Now we have classification algorithms, which is including supervised learning, neural networks, which already I have completed in previous videos. And so we are using these, which is having uh, models like BERT or legal corpus. On a legal corpus, then we have post processing. I'm sorry, I've mistaken. It is multi-level classification, in which we have multiple sections. Like there can be more than one sections applicable on a complaint, because more than one criminal activity could have been happened. So here theft has also happened and assault is also done, which is a serious issue. So we have used multi-level k nearest neighbors or multi-level decision trees to handle these overlapping categories, because none of them can be spared and the criminal must have been charged on these two or more crimes which he have performed or he have done. And then we have legal knowledge integration, which uses a knowledge graph. So applying these methods on given complaint, let's uh, have a look on the use case of whatever we have so far covered, which is pre-processing and named entity recognition. So we have date, location, object, action, and description extracted from our complaint. Then we are mapping the keyword, such as stolen word is mapped to the section 378 379. Then we are also taking the cues, like unknown person can also hint to trespassing. And then we have used semantic and legal mapping. And then classification of the pipeline, like pre-processed text into clean tokens using embeddings, and inputting the data into classified train IPC BNS mappings. And then we have retrieved these top predicted sections, which is 378 379 of theft, of which is of high confidence, because we are like kind of very sure this theft has happened. So these conditions, these codes can be applied, but trespassing is a thing which can be or cannot be. So here's low confidence, which requires corroborating evidence, because we don't have evidence of these things. We are just having we are just taking into charge this code just by the word of unknown, because it can be associated with trespassing. Now technologies for implementation can be NLP libraries, machine learning frameworks, legal ontologies, and text annotation tools. Okay, so moving on, the next question. So far we have covered the technologies or the methods which we can apply. But what about the data structures and algorithms? Because if we want to apply some technologies or methods, we want to first store the data. And to store the data, it is very important to store them in a suitable data structure, so that we can fetch the data and store the data and access the data simply or fastly. Now, this question is question number 3. What are suitable data structures and algorithms for addressing the task described in above question? So here we can use text representation of the words, like bag of words, TF-IDF models. Then we can have word embeddings, which have pre-trained models, and contextual embeddings like BERT, Roboto. Then for knowledge representation, we can use ontology or knowledge graphs, because we have to link the things. So we have to represent the relationships between legal terms and IPCBNS sections, so which can be done uh, very easily using graphs. And we can use tree here for fast keyword lookup, and for efficient rule based mapping for dictionary based classification. Also, it could be there for the relationship description purpose. Data structures for pre-processing can be used using hash maps and dictionaries, because we have to store the frequency of the words which have been repeated. So we can use hash maps and dictionaries associated with the word. Like hash maps can be used to store the frequencies, and dictionaries can be used to link the word to appropriate sections, like stolen with section number 378, section number 379. Similarly, there can be for assault, for murder. For these types of words, we can have different sections. For queues, for streaming complaints or processing pipeline, we can use queues. And for higher priority, because for ranking of IPC and BNC, according to the seriousness of the criminal activity or the strictness of the rules, or we can say the duration of the punishment, can be set by using priority queues. Now, so this was about the data structures. Now, moving on to suitable algorithms, we can use pre-processing algorithms, which is text cleaning, stemming, lemmatization, or named entity recognition, which I have already discussed in the previous video. And we can use classification algorithms, which is ML, based learn algorithms, machine learning based, which is traditional algorithms like logistic regression, naive Bayes, and effective TF-IDF, BOW futures, random forest, and we can also use deep learning models, which can be recurrent neural networks for sequence modeling of text, but it is not used very commonly nowadays. Then we can use transform based models, which is BERT, ROBOTA, and we can use convolution neural networks. Now, also we can use rule based algorithms, which is keyword matching and regular expression. Also, we can use semantic and contextual understanding, which is semantic similarity and topic modeling, and multi-level classification also. So example of the data structures and algorithms which we have discussed so far is using a hash map for stop word removal and applying regex for extracting dates, location and entities, because doing it by human for so many complaints is tedious task, and we have the goal of automating this process. And then mapping can be done using tree ontology for words to their IPC sections. Then we can convert the complaints into vectors using BERT embeddings, which is feature extraction. Then we can classify it using embeddings to a transformer based classifier. We can also use multi-level prediction to predict applicable BNS or IPC sections, and we can use post processing. So this was about the data structures and algorithms. Now let's move on to the fourth question, which is how these structures and algorithms can be applied effectively and can be classified the complaint to appropriate IPC or BNS sections. Because if we know until now that what are the structures and algorithms which can be used, but how can they be used? Let's work upon the complaint which we had. So let's have this use case of these algorithms and data structures. So the complaint was theft of my mobile phone by an unknown person at MG Road on 2023 to 20. The phone was stolen when I was shopping at a store. The thief was wearing a black jacket and had a scar on his face. So the key algorithms and data structures which we can use on this particular complaint is this regular expression, which can extract the data such as date, location and object, because these are the key features of this complaint. In order to um, investigate this whole thing, we have to know the date, location and object. Like, this is a theft activity, so we have to get the object which is theft, and then we have to store the name entity recognition, which is person. What is person here? He is an unknown person, and what's his description is he had black jacket on, also he had a scar on his face. So we have used named entity recognition. Then we have used hash map for stop word removal. We have removed the word like by, on, at, because these are not very important to our complaints. As small number of as small the complaint is, as least the number of words in our complaint can be, we are trying to do that so that it will become more easy to understand and more easy to draw the insights from the complaint. Then we can use tree for keyword extraction, like theft or stolen, to link the relevant IPC sections. We can represent the text using TF IDF by converting the complaint into numeric format by assigning importance to words like theft, and theft which is of high importance and store is of low importance, because what activity has been done is of very high importance. Like, what is the issue here? Like, when a person was shopping in the store, like, it doesn't have much relevance to the complaint. Then we have word embeddings, which is using BERT. So here we have used pre-trained BERT model to capture the context and semantic meaning of the complaint, which embeds the encode which encode the relationships between words like theft and stolen. So these embeddings are encoding the relationship between the words here between the theft and stolen. Then we have legal mapping using graphs to represent the terms and their sections, and then map theft to the sections which are related to their complaint, which is theft definition or punishment for theft, which is IPC section 378 and IPC section 379. Then we can use tree or hash map for rule based mapping, which is matching the word like stolen or theft to the IPC sections. Also, we have classified using the algorithms which are supervised machine learning and transformer models. We have done this using TF-IDF values and named entities to train a model, and then we have got the output which have high confidence on these sections. And then we have used transformer models to predict the documents. And then we have used this ranking and output to use we have used these IPC sections. We want the priority of which is to be used in this section, so we can use priority queue. Here IPC 370 has the 95% probability and 379 with 90% probability, whereas 392 with 20% probability. So we can clearly see that here the priority is for IPC 378 and then IPC 379. So this is the complete workflow of this uh, data structures and algorithms. So advantages of these approaches: efficiency, accuracy, and scalability. So this is it for today's video. In the next video, we'll cover the last question of this internal one.